Question 1 of the 2021 mechanics past paper is about a particle at rest, and it's in equilibrium on a smooth horizontal plane. So there's no friction here, it's in equilibrium. What we're going to be doing is we're going to be equating the horizontal forces and equating the vertical forces. But before we do that, we need to resolve this 28 newtons. We don't need to resolve these two forces because they are already either horizontal or vertical. So that 28 newtons is going to be split up into a horizontal component and a vertical component. Now, if we treat the 28 newtons as the hypotenuse of a right angled triangle, well then our horizontal component is going to be therefore the adjacent. And when we use adjacent and hypotenuse, we use cos. So the horizontal component to the 28 newtons is 28 cos theta. Similarly, 28 newtons if it is the hypotenuse, and we want, in this case, the opposite. When we use opposite and hypotenuse, we use sine. So the vertical component is the opposite, which is 28 sine theta. So our 28 newtons at an angle can now be changed into 28 sine theta acting upwards and 28 cos theta acting to the right. And remember, we still have 14 newtons acting to the left and this unknown p acting downwards. Now, to find the value of theta in the question, we're going to equate either the horizontal components or the vertical components. Now, there's no point in equating the verticals just yet because we have two unknowns there. So what we're going to do is equate the horizontal components, because that allows us to find theta. If we set 28 cos theta to be equal to 14, we'll then divide through by 14 and do inverse cos. We get theta to be 60 degrees. Now that we have theta, we can actually use that to find the value of p, because now what we can do is we can equate the vertical components. So 28 sine theta, now that we know what theta is, let that equal to p, so p is therefore 28 sine 60, which is 24.25 newtons.